Yeah, welcome to the presentation. It's AI with Drupal, and subtitle large language models. LLMs are quite easy to use. Many of you have probably already done so. But like if it comes to building useful applications, you know, there's like lots of things you can do, and that's what we want to look at together today. So we're a small group, we're close, so it can be interactive, and interrupt me at any time. We can discuss. If you feel don't understand, you want to add something, let's just make this interactive. I feel that's more fun, so please do so. Before we start, just let me quickly introduce myself. I'm Christoph, so I have a computer science background, and I've been doing this for quite some time, and I'm one of the co-founders at Wonix Internet. And what I do mostly there, or what I'm most passionate about, is everything R&D related. So all the stuff we do, I'm usually involved in, and of course AI is part of this too. So that's just so awesome to play with this. You find me on social media on Drupal with by my last name. And just briefly about our company. So we consider ourselves a software company. Yeah, so we're really good at building Drupal and related stuff, but we also just offer this in a full service, because in all web projects it starts with strategy and consulting, and then there's user experience and design. Then you need to develop it. In our case, we only do Drupal and React. These are our weapons of choice. And then, of course, like if you have something up and running, you need to track it, you need to optimize it, and you just need to make online marketing work, and then you need to host it and maintain it and support it. So that's what we do. We are a team of 85 people. Our headquarters is in Frankfurt. That's also where I am from. I'm married to Patti. She's Icelandic, so that's why we have an office up in Iceland. Started at some point, and now we have a team there as well. And yeah, and we also have a pretty large team in Spain, so that also happened at some point accidentally, that we ended up there, and it's not a bad place to be at all. And yeah, we're very international. We speak 18 languages. The primary language is broken English, and we're 10 years old. Yeah, obviously in 10 years with many people, we've done a lot of projects. So here are some of the logos. And but yeah, for today's presentations, AI with Drupal, and LLM is easy, but like, how do you make this useful? So for this presentation, the know-how in this room is probably very different. Many of you are maybe already experts in AI, have done lots of things. From others is maybe completely new. So let's try to get on the same level, yeah, and then just rattle some ideas, yeah. So I want to try. Or I would like to start with just making sure that we all understand how large language models work, yeah, because that will facilitate the discussion that we do afterwards. And I will show you what you can do with AI out of the box in general and with Drupal. And you will understand how you can build your own applications, generally speaking. So these are the goals. And yeah, and for inspiration, we will just look at some stuff that we've built, and I'll introduce a little bit concepts, if you want to just build your own, how would you go at it. So here's the agenda. So we start with overview, we do some demos, then we build dynamic applications, and then how to create useful applications. If you want to follow along, here's the QR code that links to this presentation. The agenda comes up again if you're too slow of making the photo now, yeah, so then you will see this again later. All right. Let's start with large language models. Yeah, so generally, when we speak about AI applications, we are usually referring to large language models. ChatGPT is a large language model. You talk to it, you say something, it responds. Yeah, and in this case, you're actually interacting with a large language model, and that's also what we refer to for this presentation when we mean AI. Yeah. And this thing is called generative AI because it generates something. Since it's a language model, it generates text. Yeah? And if you want to think about it, a large language model is a statistic application that predicts output text based on input text. Yeah, it's as simple as that. You stick a piece of text in, the large language model comes, and it just predicts what would be a sensible answer for this input text. As simple as that. There's nothing more to know about this, yeah. But these large language models, they become just so powerful, so you've tried this all, yeah. So it feels like you're talking to a real person, and that's why we also refer to this as artificial intelligence, because it feels intelligent, yeah, and it feels like real conversations. But what it is under the hood is just statistics that predict the next word in a sequence of words and sequence of tokens, as a matter of fact, and that just generates your output. Yeah. And how does this work under the hood? So these large language models, they're called large because they are just like trains with like huge amounts of data. Yeah. And in all these data, these many documents there, they have like structures inside, intrinsic structures, like grammar, for example, like good morning, good afternoon, like good prediction would be morning or afternoon, depending on the context, it changes. Yeah. So all these relationships between words and sentences or data pieces in general, yeah, they are uncovered, and this is what I'm trying to show here in this picture. They are uncovered by training the model. So you feed a lot of data in, try predict output text, see if it works. And by doing that very many times, you uncover these hidden, these intrinsically existing relationships, yeah? And that's what makes up your model, and that's what makes up your application, that you stick in a piece of text, and it can very good predict like a sensible answer. Yeah. So that brings to the first common question that you often think about: should I train my own model? No, you can't. This is impossible. Like you're simply not capable of like taking so much data which would be needed, prepare that data in a way that you can actually use it for training, and you also don't have the resource available to train a model that does this. And to just generate like a large language model like as the ones that you're used to using. That's why also you see in the news like all these crazy fights that are going on between OpenAI and Llama and Mistral and all the ones, because they're heavily financed, because it's just a big money game of like getting the most amount of data in, and having the most computing power for making the most biggest model that can solve most of the challenges. Think about it, like if you ask ChatGPT, you can ask like for what's 2 + 2. So there's a piece of text where that's written. You can ask really difficult questions, and he or she can also like give you a good answer, because somewhere in this text corpus was the answer to that, and the model can predict it. Yeah. So no, probably not. I mean, there are some edge cases. We're not going deep. So you could train your own model. Yeah, if you're just really focusing on something very niche, if there's something that you just have that's very specific for yourself, that could make sense. Yeah, but like here for this discussion, for the general thing, is that should I train my own model in case I want to build applications? No, probably not. Yeah. So, summarizing, a large language model generates text. Yeah, it's a software that can make grammatically correct sentences with a very high probability of making sense. Yeah. And the generated text is based on the training data. Yeah, we saw this. Data is used to train a model. So, therefore, if you think about it, yeah, you can think about like a large language models about like as a software that can talk, yeah, but it can only talk about something that it knows. Right? Obviously, if the documents there didn't contain 2 + 2, it cannot answer that 2 + 2 is 4. Right? Because if it's not part of the data, it can't answer that. It's the same as us. If you ask me something that I've never heard, I cannot give you an answer, same logic. Yeah? So it's a software that can talk, and that's a software that can only talk about what it knows, meaning what it was trained with. Yeah? All on the same page so far? Good. So, therefore, like if you wanted to talk about something that it doesn't know anything about, you need to feed that to the system. And that is what's called in-context learning or pre-prompting. There's very many ways of like naming this, yeah? And what that does is, or in a typical setup, like here you see on the left side, you see the prompt, that's the question the user asks, and you pass 2 additional pieces of text along. One would be the instructions, how you want the large language model to respond to that question, and the second one would be data that the large language model should use when responding. Yeah, so you say, do this and that, or what's the answer to this and that, yeah? And then there's 2 more texts being passed along. Yeah, and these 3 texts are sent as one prompt to the large language model, and that generates the answer. And this simple thing just like allows you to build your own applications. Yeah, because you just simply add 2 more messages, and then in a narrow context, that would just do what you want. So instructions and data input, and this data input is called in-context learning or pre-prompting. All right, let's look at first demo here. So I made something for this presentation here. Look, so I'm now on, zoom in a bit, on demo website here. So I created a demo for DrupalCamp Scotland. So here's like a chat assistant. Yeah, it's readable, isn't it? So you can say, all right, so list the sessions, please. You don't have to say please, he or she doesn't care. And so what now happens in the background, I'm scrolling down a little bit so you see it. So I'm passing a system prompt along saying you're a friendly assistant, you know, you have some information about the Drupal camp in Scotland, and be friendly and give information. Pass that information back in Markdown format. You see that here, Markdown's coming back, and you also see that the chat application doesn't interpret the Markdown correctly, because you know, Markdown, you'd like 1111 should be interpreted as like an ongoing list, like you know the JavaScript application is not smart enough to just understand this, and yeah, and answer short and precise. And if you cannot answer, just point to this website. Yeah. So here was the first question. So and the data I fed in was just simply the information that I found on the website. So I went to the schedule, I went to the speakers, I took this all, I formatted this as Markdown, well, yes, actually Markdown, yeah. And because Markdown is very reduced syntax, because like the simpler the information you pass to a large language model, the easier it's to understand, and then you can answer. So let me ask some more questions. Here does Billy have a session? Yes, so Billy has a session. Billy, where are you anyways? Oh, there, yeah. So you have a session, okay, good. What's the session about? So it's using OpenAI here, so there's a request now going to OpenAI, AI, and it's coming back, so that's actually the latency you see here, so there's nothing really going on the page here. All right, so what you see here is like a full-blown application that is just like a, you know, program explainer, session recommender, you know, like attendee guide. Yeah, and like whatever you feed into the system, you know, the application can attend. Yeah, it's not possible with ChatGPT because ChatGPT doesn't know anything about DrupalCamp. Yeah, and so like that would be like first and most simple way. So we can do a couple more things. Let's have some fun. Let's say, oh, he's he's telling me a lot more. Okay. Oh, he didn't even tell me. No. So that was wrong. No. Tell me what Billy's session is about. Okay, good. So like, is Billy good looking? So he doesn't know, yeah? So, and he said correctly, so you saw here in the system prompt, you said if you don't know, you know, point to the program here. So, okay, but we can fix this here. So let's go to chat assistants. So here's the configuration for Scotland, DrupalCamp Scotland here. And you now see here, so let's close this, we'll get back to this in a second. So we have here the text, you know, so as I said, I just simply took like what is available on the website, you know, put this all into Markdown here. So here the first one's about Billy's session, that's just exactly the code that was there. Then Phil's session and so forth, Lenny, yeah. And here's the message, you know, the initial message, you know, the welcome message is here. And here's the system prompt saying, oops, this is not needed, go away. You know, saying that you're a friendly assistant and so forth. And now we can just, for example, just add here, we could say, Billy Wardrop biography. He is very handsome. Yeah. And now let's see if we can improve the answer a little bit now. So let's go back to the site. Okay, so what does Billy look like? Right? Yeah. So far so good. So this is just what this does, you know, like add stuff in and like tailor it. So like we can have some more fun here, like have some more ideas. So we can also say chat assistants. So of course he's very, I told him to be like very dry and like very professional. So you can of course also say like Scotland, you can say, you can also do stuff like, say here, answer short and precise, be ironic and sarcastic, throw in a joke once in a while. So let's see what it does when I tell him to do this. So let's go back here. Okay. So I heard the camp has a very cool program. Tell me about it. So think a little bit more now. Oh, he's probably not handling the coffee. I didn't put that in, so he must have guessed this. Yeah. It could be the coffee. Maybe it's not good for him. All right, so you can have some good fun. We can get back to this and we can play a lot more later. Yeah. So what did we? So if you make yourself an account on the page, you can actually try it out yourself. It's good fun. So we had here, so there was like the instructions, you know, the ones that we just changed, yeah. It's really straightforward. You also like read about this prompt engineering, like about all this. I mean, yes, if you want to do like more difficult things of like first asking this, then asking that, and then generating something else, you know, so then of course like you just need more understanding of prompt engineering, but like in this general use cases like this, you just tell what you want to have back. Yeah, you put in data like in a structured way, like models love structured data, and Markdown is just like very suitable for this. And then you can make these types of applications. So I want to show something here because I held a similar presentation in DrupalCamp Barcelona. So the UI that you just saw is exactly the same. It's just it's a different chat, yeah. And I want to point out a couple of things on a different example. And what I'm getting at is that like I have like the max tokens here is much higher, and that's what I actually want to show you. That's why I didn't make screenshots now from this chat here. But the first thing that you see, so in the configuration, I used to model the GPT-4o Mini. Yeah, so if you've ever like tried around and played around in ChatGPT, you know there's very many models. Yeah, and the Mini model is a small model. So there's large language models and there's small language models. And small language models can still speak grammatically correct, yeah, and can still very good predict like output text, but it's just much smaller. Is trained on a much smaller corpus, so the model is smaller, and it can just generate your response much faster. Yeah. So, and because it can just generate the response much faster, it's cheaper. Yeah. So that's why like these big models where you can like throw in like huge amount of data and you get very sophisticated answers back without having to like pre-prompt or send stuff in, they are much more expensive. Yeah? So that's something that, for example, that you want to consider like for your own applications, like depending on what it is that you want to do, you have to select the correct model, and ideally you select the model that's as small and efficient as possible for the task that you want to do. Yeah? So in this case, the smallest model from OpenAI is absolutely suitable. The second thing is here, we already saw the static text. So for DrupalCamp Barcelona, obviously the session program is much, much bigger. Yeah? So when you just take the full session program from DrupalCamp Barcelona, and you just calculate this into, this one here, and calculate this into conversation tokens. So internally large language models work with so-called tokens. Yeah, so they actually don't have words on the inside. So like when you send in a question, it gets transformed into tokens. These tokens are evaluated. Response tokens are being returned. These are then translated into text, and that's what you get back. Yeah, so therefore internally you just talk about tokens. And so text converts to tokens on average like a word is usually 3 to 4 tokens. And no, sorry. Yeah, I think so. And anyways, and so if you take the full session program, you just have a like very large amount of tokens, and when you use APIs, you charge by token. Yeah, so therefore like this high number here, because on the next slide we're going to do some calculations, so you get a feeling for when you create an application with a lot of content, how much does that cost. Yeah, think about the university. If you want to make the university fully available on large language model, I mean, you can't afford it. Yeah, at least you cannot afford that many people ask questions. And so here, so that's what I do there. I want to point out another thing here. So I'm pointing to the maximum number of messages. So when you think of a conversation, so we ask like, so list the sessions, what's Billy's session about, and like, you know, whatever other questions you would have about the program. At some point, questions that you asked earlier in the conversation don't matter anymore. Like just like when we talk now, so I said some things like in the beginning that you've already forgotten, yes, they don't matter anymore. Like same thing here. Yeah, and so therefore, like also what you want to do in the conversation, you just want to control like how many messages are being sent back and forth. Also, just simply for the purpose of just like, you know, when you send long questions, long answers, it costs money. Yeah, it costs computation time. It doesn't matter if you host yourself. Yeah, so you just want to like control like what is the maximum amount of data you want to allow to flow through, and like how many messages do you want to allow. We did for DrupalCamp Barcelona, we did a calculation, yeah, and the full program was 21,000 tokens, yeah, and on the price for the GPT-4o mini model, where you just you're charged on input tokens, so the questions that you ask, and like you know here you send every request you send here 21,000 tokens plus everything else that was before, like the questions and the previous answers and the questions and so forth, yeah. And so you charge an input-output tokens, and if you then assume that like in a conversation like this, you know, a session recommender for something of the scale of DrupalCamp Barcelona, and if there's 10 questions that you ask in a conversation, that actually costs 4 cents. Yeah, and 100 conversations, then of course $4. Yeah, 1,000 conversations, $40, and like for a conference with like 1,000, 2,000 participants, like probably it gets too expensive right away. Yeah. All right. So, what can we do? You can, of course, just not always send all the data. Just send only what's needed for the question. Because when you ask, what's Billy's session about? I don't need to send the information about Lenny's session or about Stratos' well-being. Yeah? So just what Billy is talking about is relevant to answer this question. Yeah? And this is called Retrieval Augmented Generation. Yeah, so you hear this buzzword and it sounds really fancy and everybody likes, ooh, RAG, yeah? So it's really nothing else that you have a pre-processing task that just like based on the question finds the data that's relevant and passes that along together with instructions, and then everything the same and the answer is generated. Yeah? So here for retrieval, like there's 2 things that you just want to pay attention to. So retrieval can be search, but this can also be anything. Yeah, so for example, if you now think about an application that works in a checkout process in a Or no, let's say maybe you have a support a bot for like an e-commerce store, or maybe like what we discussed earlier, you have maybe like a student support portal, yeah? Then you want to load contextual data for the student. So in this case, the data that's loaded is not all students or all orders, just the orders or the contextual data for this particular person, yeah? So that would be data loading. And then for searching relevant content, this can be anything. This can be semantic search, can be regular keyword search, whatever it is, yeah? So let's look at this here. So I could show this live too, but like here's a video and it runs a little bit faster. Yeah, so this is from our intranet. And what we do here, wait, I just actually want to pause. Oops, no, go back. Before I start talking, otherwise you can follow. So we have an intranet in our company, yeah, and this has a lot of information. Has information about like vacation, about coding, about project management, about like whatever there is, yeah. And we make that available via a chat interface, like what you just saw, yeah. And there's a video coming up for this, and to make you understand like how this works. So all the content is just indexed. In this case, it's indexed in a semantic index, yeah. And semantic index means it uses semantic similarity and not keyword search. You know, like you've all built searches, or the developers here, or, you know, have all built searches before. Like keyword search works on the words. So if you look for dog, dog needs to be on the page in order that the page can be returned as a result. But if you search for a wow wow, yeah, that will not return anything unless you use semantic search, which captures the meaning of captures that there's a similarity between dog and wow wow, yeah? And so here's indexed semantically. And now here is like, took some typical answers, yeah? So that's like somewhere, so you see there's a navigation, like there's this docs, and there's like all kinds of areas where deep down you find like how vacation can be requested, yeah? And so we've configured like here the application to behave like this, that it just gives you a summary of that page, but it gives you a link to where this information was found, because you don't know in this type of application, you don't know if it's good enough to, so maybe the answer is good, like 6 weeks in it, or like here, like do you have to pay travel expenses yourself? Yes you do, or yes you don't, yeah, so that answer is just maybe good enough. In some other cases, maybe you want to go to the page and read. So it's configured to like give the links in the end. What happens under the hood is that when a question is asked, a semantic search fires, yeah, and it looks for matching pages, you know, for the question, yeah, loads these pages as a pre-prompt and passes them along for the question, yeah. In the configuration, it's done like this, that you just need to have a minimum, you know, similarity from the question to the result page, so that it actually starts being considered relevant of passing in. And then the algorithm just like appends this, and at some point, remember this 10 messages that we had there? At some point also it just starts taking out previous messages and previous documents, because we want to be efficient within the data that we send. You see here, I completely switched the context. Yeah, so you see then new information is there. So this was a coding related question. So other typical questions is like AVL, that's just one of our clients. So sometimes maybe you would like to know, like, where's this hosted? And what else did I ask now? Yeah, so now I'm switching context like for project management, and yeah. So this is really useful. And now there's lots of university people here. I think that's actually a brilliant use case for you, because you have like these deep nested information. And if you actually want to surface stuff that's living very deep, you know, that's how you can do it. And it just has the links. It takes you then to the page directly, and you don't have to do this, what you usually do, go to the page, find the CTA that's relevant, or go here, all courses are this course, or sign up, or results, and so forth. And yeah, and you just save like clicks, yeah. Yeah, this is just here more random examples. Yeah, I think I'll just go on. We can go back to this, and we can try this live if you would like. Let's continue. Okay, so how does this work? So that's just regular Drupal functionality. So we use Search API. So we have just defined here another database, a vector database, this one here. So we use an open source product here called Milvus. Yeah, there's a bunch of them out there. There's also paid services, but Milvus open source project, you can host it yourself. It works just really well. And we do a couple of things. So just like in the application that we saw earlier, so where I manually converted the session schedule to Markdown, we just do this here before indexing. So we take the rendered page just like you would with Search API for general searches. You also, you index just the stuff, the HTML you usually index. We do that here too, strip the HTML, and then convert the HTML to Markdown, and that's just what you want to index. Yeah, and you see here there's really nothing special about it. We pass the URL to the document along, because in the instructions later you will see that it says give the URL at the end of your message, and the rendered item. So we use here the standard render method with a view mode that's specifically for indexing, and we just index this as so-called embeddings. Embeddings, that's another special word that you might have heard already. So embeddings is what you convert your text to in order to be suitable for storing for semantic search, and that's exactly the same what's happening like when you just access a large language model. So embeddings it's actually a string of numbers, yeah, that represents your text based on your model, and that makes it really, really easy to find similar text, because like text that has so these numbers, you can consider them as a vector. That's also why we refer to this as vector databases, because like a number of sequence of numbers, that can be considered a vector in the multidimensional space, and you can very easily and efficiently compare this with other sequences of numbers that have like a similar line in the multidimensional space by taking the cosine distance, for example. It's very efficient to find similar content. That's how this works, and that's what embeddings are. All right, so the instructions are super simple, friendly, and professional again. Yeah, so the content is separated with something very, very unique, so the large language model doesn't get confused. And yeah, when creating this prompt, yeah, it was easier because in the end I want to say, look here, the links from the document source should be printed at the end of the document, yeah, and in this particular format, yeah, so the large language model gets the response right, and it was easier to pass this along as HTML, so that's easy to understand. But in general, just like give me everything in Markdown, and yeah. So now, if you go to, we did another thing in our intranet, because if you start like making all your content available, you just have to be really careful that remember, the model can only tell you about stuff that it was previously told. So if the stuff that you're asking about, you're not passing it to the model, you won't get a good response. And so therefore, if you're passing data formatted as Markdown, you just need to have a way of seeing your Markdown to check if this is there. Because like the use case you will have, let's say you're in university, you want to say like, what's the sign-up deadline for course XYZ, yeah, and it doesn't show up correctly, you need to be able to debug it. So you go to this page and you click on, and this is what we've built for ourselves here. So we've built like a Markdown view mode for nodes, where you can click on show me as Markdown, and then it asks you, okay, which view mode do you want to see in Markdown? So the one we use for indexing is called search index. Yeah, click on search index, and then you see it, and then you can also see like, okay, that's the problem. Yeah, that's why this particular information was not indexed correctly. That's why it couldn't be found, or it couldn't be, or the answer could not be generated correctly. Yeah, so something like this you most likely need, because otherwise you can't work with your content. Yeah. So here for the retrieval part, so you saw in the last screen I showed, there was just static text, this piece of text that I dumped in, where it started with Billy and so forth. Yeah, so here now the feed source, this is like, we've created this ourselves here. So the feed source comes from the vector database, so that's where the data comes from. And we just want to have from our vector database 5 results, and we want to have a minimum similarity of 0.2. Yeah, so that's also something that if you build these types of applications that you need to be aware of, because like dog and wow wow, is that now similar enough, or is that not similar enough? That depends on your data. Yeah. So you put this in, and you just have like these vectors for comparison. They come back with a similarity score, and you just need to work with your data, and you need to work with your audience and your questions and your responses in order to just get this right. Yeah. The rest here is the same. So we have here max 10 messages in a conversation. That feels logical to me. That seems to be kind of good value. And you see, remember we had here in the max tokens. Did I put an arrow there? Yes, I did. So in the last one, like the example from DrupalCon, there was 21 tokens that we needed to be able to send along, because just the first question is already like 20 tokens, yeah. And but here we can put this down to like 4,000 tokens, like something really, really small, yeah. And even though we have a much larger like corpus of a set of data that we actually can answer questions about. All right. So if you build this, what you probably also need is logging. Logging or optimizing chat assistants is difficult in the first place, because every question is different, every answer is different. Yeah, but it all starts with you just need to log this, So you need to say, look, this message was removed because it was too many messages. This message was too long, so it was cropped, and more was removed, and then, okay, now after removing everything, these are the messages that were sent, and that's the response that I got. Yeah, so you need this, otherwise, you just won't know, why am I seeing the answers that I'm seeing. Yeah. All right, and all of this is pretty standard. You can do all of this with Drupal, yeah, with contrib modules that exist today. The only thing, so we didn't use the AI Assistant API and the AI chatbot, is just simply because we had ours before this was developed. We contributed to these. We will essentially at some point change to these. But for the moment, because we're actually actively building this for clients, so we need to have this piece of source code under our control, so we can make innovation on it and tailor it the way we want. Yeah, and but everything you saw here, we use as much from contrib as we can, and we of course contribute everything back that we can. Yeah, but you can build this yourself today, with the modules available in the contrib space. Most likely, the chat assistant itself, the JavaScript application that didn't correctly format my markdown in the beginning. Yeah, so that's maybe also something that you would probably want to control yourself, because a good chat application depends on the UI. Yeah, and that's actually where probably, if you want to make a good experience for your audience, that's what you have to do yourself so it really fits to, because there's a big difference if it's what did we have here, degree finder versus I don't know, something else. Yeah, so they probably need to look different and so forth. Yeah. Yeah, so markdown conversion is not hard, it's a library, but it's just custom, it doesn't exist yet, and this previewing we just built ourselves, but these are just small ones. Okay. What about, okay, wait. So far so good? Questions? No, I'm not finished. I'm just saying, I was just give the opportunity to, yeah?
Obviously you're involved in Search API recipe for Starshot.
Yeah.
I'm wondering how much of this were you considering?
Hold that for there will be Q&A at the end of the session. I just wanted to I want to make sure that everybody's still following. That's what that was. Oh. Are we out of time already? Yeah, okay. Fine-tuning, you've heard that before, so what does that mean? So fine-tuning is you can take a model and you can add data to it so it gives better answers. That does make sense if your content doesn't change frequently. Then instead of passing this along, you can fine-tune it in. Same, but fine-tuning is better, it's more efficient, because then faster, if it's already in the model, you don't have to send anything along. Yeah. So and there's nothing more here, but except this one, which I saw on an AI conference, which I think is really nice. How do you find use cases? Yeah, and that's just a really good way of thinking about it. If there's a step in the workflow that AI can do, let it do it, or if it can just support, let it support, and if not, let's wait a little bit. Yeah, but really.